So here is a normal distribution question that involves the length of nails. So we're going to talk through this one. Again, we did this in class, but this is just for your benefit to go back and review. So it says a machine manufactures a large number of nails. The length of nails is normally distributed where L is a normal distribution. That's what that means, that little symbol with the capital N. And then it says the normal distribution has a mean of 50 and a standard deviation of sigma, because the variance is sigma squared. So it says to find the probability that between 50 minus sigma and then 50 plus 2 sigma. So the problem is with this question that if I want the probability, let me just erase that. That's a strange P. I want the probability that X, or L in this case, is between these two numbers. We need sigma if we're going to use our calculator. Okay, generally speaking. We don't have sigma, so we have to convert these to z-score. So that is the mean, right? And that's the mean. So to convert these to z-scores, I can say the mean of a standard normal distribution is 0, and sigma is 1. So I can convert these into this. So it's the same probability as z being between minus 1 and 2. Okay, so I'm just switching from the regular distribution to the standard distribution, and then I'm just going to go ask the calculator to do that. So I'm going to do a normal distribution, and I'm going to do a normal CDF, and my lower bound is going to be minus 1, and my upper bound is going to be 2. And I'm going to hit OK. And it's 0.818 is what it rounds to with 3 significant digits. So 0.818 is our answer. Okay, so that is part A. We just switch the normal distribution to the standard normal distribution, and then we can find the probability. Part B, we look back at the question, says find the probability, or sorry, not the probability, find the sigma if the probability that the length of the nail is less than 53.92 is this. So it gives us a probability, 0.975. So the probability that X is less than 53.92 is 0.975. So we know that. We also know that our mean is 50. Okay? And we need to know sigma. That's what we're looking for. So I'm going to find my Z value from the probability. I'm going to do an inverse normal of 0.975. That's going to give me my Z value. So I'm going to go to my calculator, and I'm going to go to menu and statistics and distributions and inverse normal, and I'm going to put the area as 0.975. And it's 1.95996. So I'm going to put in 1.95996. So sigma then, if again we return to our Z is equal to X minus mu over sigma, and I solve for sigma, sigma is X minus mu divided by Z. So I get 53.92 minus 50 divided by 1.95996, and that is equal to 2. So that is part B. Then it says all nails with length at least T are classified as large nails. A nail is chosen at random. The probability that it is a large nail is 0.75. Find the value of T. So for part C, again, we're given a probability. We're given the probability that X is greater than T is 0.75, which means if we're going to switch that to a less than, that the probability that is less than that is 0.25. Okay, we know the mean is 50. We know the standard deviation is 2. So what we can do to find T is just going to be the inverse normal of 0.25, because a normal distribution, the inverse normal function of the normal distribution always gives you the less than probability. It always tells you the value for which this probability that you're taking is less than that number. So we just have to use the less than part. We can actually, on our calculator, put in 50 and 2, though, so we don't have to go through the Z value. So we go here and we just go to our inverse normal. We can change the probability to 0.25. We can change this to 50 and this to 2. And we get 48.651. So 48.651 is our answer. If we round that to 3 significant digits, it's 48.7. Okay? So that's the answer to part C. Then it says, a nail is chosen at random from the large nails. Find the probability that the length of the nail is at less than 50.1. So now we go, okay, we want the probability that X is less than 50.1, and it's given that, so I'm going to say that it's also greater than 48.7. Okay, so we're talking about conditional probability. We're doing A given B, where A is less than 50.1 and B is greater than 48.7. So we're going to end up with a probability on the top that it's between 48.7 and 50.1. And on the bottom, we want the probability that it's greater than 48.7. So that's going to give us, on the bottom, we already know this probability is 0.75. And on the top, we have to go find that probability. So we have to do a normal CDF. We want it to go from that number, okay, up to 50.1. Our mean and standard deviation are back here. We're still using this, right? Even though it's a ways up in the question. So the mean is still 50 and the standard deviation is 2. And sometimes you got to remember that it's all one question, or it's all part of the same question. So there's 50 and 2, and we get 0.269939. So 0.2699. 0.2, whoa. 269939. Okay, and then we're going to take that number and divide it by 0.75, and it gives us our probability, and it's 0.3599, so it's 0.360 if we round it to 3 significant digits. All right. And then finally, the last part of this question says, 10 nails are chosen at random from the large nails. Find the probability that at least 2 nails have a length that is less than 50.1. So we're choosing from the large nails, and we want to know what the probability is less than 50.1. So this probability that we just found becomes our probability of success, but we switch to binomial distributions now. So we've done 10 trials. Our probability of success is 0.360, and we want to know the probability that X is, if you read the question, at least 2. So that means that X is greater than or equal to 2. So we're going to do a binomial distribution. We're going to do a binomial CDF, and it's going to be, actually, I'm not going to write this out because you can see it on my calculator what I'm going to do. So we'll just do it here. So we're just going to go to menu, we're going to go to statistics, distributions, and we're going to go down to the binomial CDF. And we're going, the number of trials is 10, the probability of success is 0.360. Our lower bound, if we look here, is 2, and our upper bound is 10. And it gives us 0.924. Whoop. And that is our final answer for the last part, for part 2. All right, so that is how you do that question.